Ever launched a game and wondered, like, how did they do that?
Mm.
Well, today we're going deep on the languages that make those gaming worlds possible.
Yeah, it's like choosing the right tool for the job, right? You wouldn't build a house with a screwdriver.
Yeah, exactly.
Different types of games have different needs, and that's where programming languages come in.
Perfect analogy. And, based on your profile, it seems like you love to understand how things work, so this is right up your alley. Our source material is a pretty detailed guide comparing these languages. We'll hit the highlights, and our expert will break down what it all means.
Yeah, we'll explore how those language choices impact the games you experience, from those indie darlings to the massive AAA titles.
Okay, let's start with those AAA games, the ones with breathtaking graphics and worlds so vast you can practically get lost in them. What makes a language right for that kind of scale?
Well, it often comes down to control. Think of a game like Red Dead Redemption 2, with its huge open world and incredibly realistic environments and complex physics. To build something like that, developers need a language that gives them fine-grained control over system resources.
So it's not just about making things look pretty, it's about making sure the whole world behaves realistically.
Exactly. Every blade of grass swaying in the wind, every realistic water ripple, all of that requires a language that can handle that complexity. And that's where C++ often comes in.
C++. That's the one a lot of AAA studios use, right?
Yeah.
I've heard it's powerful, but pretty tough to master.
Yeah, it's like the heavy-duty construction equipment of the programming world. It's robust, it can handle immense complexity, but it's not something you just pick up overnight. It takes a skilled team to wield C++ effectively.
Makes sense. You wouldn't want someone building a skyscraper with tools they barely know how to use. But what about those who are just starting out? Maybe someone who has a great game idea, but isn't a coding wizard yet.
Yeah, that's where the indie game scene comes in, and a language like C# paired with the Unity engine has been a game changer for aspiring developers.
Oh.
Unity provides a more user-friendly environment, and C# is known for its readability and ease of use.
So it's like having a pre-built set of tools that let you focus on the creative side of game development.
Exactly, and that's led to an explosion of indie games. These smaller teams can create amazing experiences without needing a massive studio and years of C++ experience.
I bet there are some indie games out there that have really blown you away. What comes to mind when you think about games that punch above their weight, so to speak?
Oh, there are so many. But one that always stands out is Hollow Knight. It has beautiful hand-drawn art, incredibly tight gameplay, and it was all created by a small team using Unity and C#.
Wow, that's impressive. And it highlights a point you made earlier, the right tool for the job. You don't always need the biggest, most complex language to create something fantastic.
Absolutely. Sometimes a language like C# and a flexible engine like Unity can be the perfect combination to bring an indie developer's vision to life. And here's where it gets even more interesting for you. C# also has amazing cross-platform capabilities.
Okay, I'm intrigued. What does that mean in terms of actually getting your game out there?
Imagine this. You create your game once, and with a few tweaks, you can release it on PC consoles and mobile devices. That kind of reach is massive, especially for an indie developer.
So it's not just about making development easier. It's about opening doors to a much wider audience. You could be playing on your PC, your friend on their console, and another on their phone, all enjoying the same game.
Exactly. That's the power of choosing a language that aligns with your goals. And speaking of goals, what if your goal is to test out a game idea quickly, to experiment and see what works before diving into the heavy coding?
Oh, the prototyping phase. I bet there's a language perfectly suited for that, right?
There is. When it comes to rapid prototyping and scripting, Python often takes center stage. It's known for being beginner-friendly and allowing you to get ideas up and running fast.
You know, it's funny you mentioned Python because I remember reading that Minecraft, a game that's captivated millions of players worldwide, actually started as a simple Python prototype.
It's true. Even the biggest, most successful games often have humble beginnings, and Python is great for that because it allows you to play with mechanics, test your ideas, and get a feel for your game before committing to a more complex language.
I'm starting to see a pattern here. It's not about picking the best language overall. It's about choosing the best one for the stage you're at and the type of game you're creating.
Precisely, and that brings us to another important aspect of game development, the platform you're targeting. If you're aiming for mobile, there are specific languages that shine in that arena.
So we're talking about games for phones and tablets. That's a huge market these days.
It is, and it's driven by two main languages, Swift for iOS and Kotlin for Android. These languages are designed to take full advantage of the unique features of each platform.
So it's about being able to tap into things like touchscreens, accelerometers, and all those things that make mobile gaming unique?
Exactly. You want your game to feel like it was made for those devices, not just ported over from another platform, and that's where Swift and Kotlin excel.
So if you're dreaming of creating the next mobile gaming hit, you've got to pick your platform and choose your language accordingly.
That's right. Understanding the strengths of each language is crucial for making those decisions. But there's one more platform we need to talk about, one that makes games accessible to just about anyone with an internet connection. The web.
Web-based games. I remember playing those simple Flash games back in the day, but things have evolved a lot since then.
They have, and JavaScript is the undisputed king of web-based game development. Its wide compatibility means anyone with a browser can play regardless of their device or operating system.
Talk about breaking down barriers. You don't need any special hardware or software. You just point your browser to the website and start playing. It's amazing how accessible that makes gaming.
It is, and JavaScript has come a long way in terms of what it can do. We're seeing increasingly complex and visually stunning games being created for the web, all thanks to the power and flexibility of JavaScript.
So we've covered a lot of ground here, from the powerhouse languages behind AAA games to the more accessible options for indie developers and the mobile-specific choices for smartphone and tablet games. And let's not forget about JavaScript, the king of the web.
And the key takeaway is this: there's no one best language for game development. It all comes down to the type of game you want to create, the platform you're targeting, and your own experience and goals.
It's about choosing the right tool for the job. And honestly, I'm finding it fascinating to think about how these different languages have shaped the games we play. They're like the building blocks of entire virtual worlds.
And speaking of building blocks, there's another crucial piece of the puzzle we need to explore: game engines. These are the software frameworks that provide the foundation for game development, and they often go hand in hand with the choice of programming language.
Okay, that sounds like a deep dive for our next segment. Get ready to explore the engines that make those gaming worlds tick. Welcome back. We've been talking about the programming languages behind your favorite games, but there's another layer to this, game engines.
Yeah.
What exactly are they, and why are they so important?
So think of a game engine as the foundation upon which a game is built.
Okay.
It provides a set of tools that streamlines the entire development process.
Right.
Imagine trying to build a house without any prefabricated walls or plumbing. That's what game development would be like without a good engine.
So it's like having a pre-built structure that handles a lot of the behind-the-scenes work, allowing developers to focus on the creative stuff.
Precisely, a game engine takes care of things like rendering graphics, simulating physics, managing sound, and handling player input. It frees up developers to focus on designing levels, creating characters, and crafting the overall gameplay experience.
That makes a lot of sense.
Uh-huh.
It's like the engine in a car.
Yeah.
You don't need to know how every part works to drive it, but it's essential for making the whole thing go. But I imagine, just like with programming languages, there are different engines suited for different types of games.
Absolutely. Some engines are great for 2D games. Others excel at 3D. Some are geared towards beginners, while others are used by AAA studios to create those blockbuster titles.
Right.
Let's dive into a few examples.
Okay, let's start with one we mentioned earlier, Unity.
Yeah.
It seems to be incredibly popular, especially among indie developers.
Yeah.
What makes it so appealing?
Well, Unity's strength lies in its accessibility. It's relatively easy to learn. It has a huge asset store where developers can find pre-made art sounds and scripts, and it supports a wide range of platforms.
Okay.
Remember that cross-platform compatibility we talked about with C#? Unity leverages that beautifully.
So you could create a game in Unity using C# and, with a bit of tweaking, release it on PC consoles and mobile. That's pretty powerful.
It is, and that flexibility combined with its ease of use has made Unity a favorite for indie developers. Games like Cuphead, Ori, and The Blind Forest, and Among Us were all created using Unity.
Wow, that's a pretty diverse range of games, from visually stunning platformers to social deduction games that took the world by storm.
It seems like Unity can handle just about anything. But what about those games that really push the visual boundaries, the ones with hyper-realistic graphics and massive detailed worlds? What kind of engine can handle that?
When it comes to raw power and graphical fidelity,
What?
Unreal Engine is often the top choice.
Okay.
It's the engine behind games like Fortnite, Hellblade, Senua's Sacrifice, and the recent Demon Souls remake.
Okay, those are some seriously impressive titles, especially visually. What makes Unreal Engine different from Unity?
Unreal is known for its stunning graphics and its advanced tools for creating realistic environments, lighting, and physics.
It's often the choice for AAA studios that have the resources and expertise to leverage its full potential. And it primarily uses C++ as its programming language, which, as we discussed, gives developers that fine-grained control that's essential for complex projects.
So it's like the difference between a high-performance sports car and a reliable family sedan. Both can get you where you need to go, but one is built for speed and raw power. But I'm guessing Unreal Engine comes with a steeper learning curve.
There's definitely a trade-off.
Yeah.
Unreal is incredibly powerful, but it can be quite complex to learn, especially for someone just starting out.
Right.
Unity is often seen as a more beginner-friendly option, while Unreal is the realm of experienced developers who want to push the visual boundaries of gaming.
It's fascinating to see how the choice of engine can influence the types of games that are created. But it seems like both Unity and Unreal have been incredibly successful in their own right.
They have, and it's worth noting that both engines are constantly evolving with new features and updates being released regularly. The competition between them is actually a good thing for game development as a whole, because it drives innovation and pushes the boundaries of what's possible.
It's like anything in technology, it's all about moving forward. But are there any other game engines out there worth mentioning? Or are Unity and Unreal the dominant forces?
Well, while Unity and Unreal are arguably the most popular, there's a whole ecosystem of other engines out there, each with its own strengths and target audience.
Oh.
For example, Godot is an open source engine that's gained popularity for its flexibility and its community-driven development.
Okay.
It uses a Python-like scripting language called GDScript, which is appealing to those who prefer a more code-centric approach.
So it's a good option for those who want more control over the code and are comfortable working with a programming language that's a bit closer to the metal.
Exactly. And then there's GameMaker Studio 2, which is often favored for creating 2D games, especially those with a retro aesthetic. It uses a drag-and-drop interface and a proprietary scripting language that's relatively easy to learn. Many popular indie games like Undertale and Hotline Miami were created using GameMaker.
It's amazing to see the diversity of options available to game developers. It seems like there's an engine out there for every type of game and every level of experience.
There is, and that's one of the things that makes game development so exciting. The tools are constantly evolving, new engines are emerging, and the possibilities for creating unique and engaging experiences are endless.
So we've covered programming languages and game engines, the foundations upon which video games are built. But let's shift gears a bit and talk about the actual games themselves. I'm curious to see how the choice of language and engine has influenced the gaming landscape.
That's a great segue. Let's explore some real-world examples of games that have achieved global recognition and see how the tools behind them have contributed to their success.
We've talked about the tools, the languages, and engines, but now let's see them in action. I'm excited to explore how these choices have shaped some of the biggest games out there.
Yeah, it's amazing to see the diversity of the gaming landscape, and that diversity is partly thanks to the range of tools developers have at their disposal. Think about the sheer variety of genres, from heart-pumping action to thought-provoking indie titles.
Exactly. Let's start with a genre that always pushes the boundaries. First-person shooters. Games like Call of Duty, Halo, Battlefield, they demand incredible performance and stunning visuals.
And, when you think about the intricate physics-detailed environments and the need for smooth action, it's no surprise that many of these games are built with C++ and Unreal Engine.
C++ for that fine-grained control and Unreal for its graphical prowess. It's a winning combination for those high-octane experiences.
Right. They need that power to handle those massive firefights and create worlds that feel both expansive and immersive.
Now let's switch gears completely and talk about role-playing games, RPGs. These are the games that often draw us in with their rich stories, expansive worlds, and complex characters.
Think of games like The Witcher 3, Skyrim, or even online RPGs like Final Fantasy XIV. They transport you to entirely different worlds and offer endless possibilities for exploration and character development.
And while some of these RPGs utilize C++ for that added power, we also see a lot of indie RPGs thriving with C# and Unity.
Yeah, a great example is Disco Elysium, an RPG that's earned critical acclaim for its narrative depth and unique dialogue system. It was developed using Unity and C#, proving that you don't always need the most complex tools to create a truly impactful experience.
It's all about finding the right tools for the job, and sometimes that means opting for accessibility and ease of use without sacrificing the creative vision. Now, what about games that have taken the mobile world by storm?
Oh, mobile gaming is a phenomenon, and languages like Swift for iOS and Kotlin for Android have played a massive role in its growth. Take Candy Crush Saga, for instance. It's a seemingly simple puzzle game that's been downloaded billions of times, and it was built primarily using Swift.
It's a great example of how a language tailored for a specific platform can lead to massive success. And on the Android side, we have games like Pokemon Go, which blended augmented reality with the real world and became a global sensation.
Pokemon Go was initially developed using Java, a language closely related to Kotlin. These mobile-first languages allowed developers to create experiences that feel seamless on our phones and tablets, taking advantage of touchscreens, GPS, and all those features we use every day.
It's amazing to think about how the games we carry in our pockets are powered by these languages, and they've changed the way we play and interact with the world around us. But let's not forget about another platform that's made gaming incredibly accessible: the web.
Yeah, web-based games have come a long way from those simple Flash games of the past. JavaScript has powered countless online gaming experiences, from agar.io, which became a viral hit, to complex multiplayer worlds.
The beauty of JavaScript is that it runs in any web browser, making games instantly accessible to anyone with an internet connection. No downloads, no installations, just pure gaming fun.
And it's a testament to the creative potential of JavaScript, a language often associated with web development, but increasingly used for creating engaging and interactive gaming experiences.
It's been incredible to see how these languages, C++, C#, Swift, Kotlin, JavaScript, have shaped the gaming landscape. They've each contributed something unique, allowing developers to create worlds that entertain, challenge, and connect us.
And as we wrap up this deep dive, I think it's important to remember that game development goes beyond the technical. It's a creative endeavor, a form of storytelling, and a way to build communities.
Absolutely. And whether you're an aspiring game developer, a seasoned pro, or simply a passionate gamer, I hope this deep dive has given you a new appreciation for the languages that power the games we love.
It's fascinating to think about how lines of code can translate into experiences that captivate our imaginations and transport us to other worlds.
So keep exploring, keep playing, and who knows, maybe you'll be inspired to create the next gaming phenomenon. Until next time, happy gaming.